Yes, so I'm going to talk about the citizen-centric uh, data democratization framework for data custodians in South African higher education. It's a topic that I came up with as an interest, as due to my interests and experiences in terms of what I see happening to our academic institution. It's a bit very, what I would say, political in the academic space because I think when you talk of democracy, many people are not so comfortable they want democracy, but they don't want to hear that democracy being talked about. So we are talking of data democratization, just meaning you are allowing users, those who were in the keynote in the morning, there was a talk on the data democratization, but that was more technical. Now we are just simplifying it to say, what does it mean to our higher education institutions and what should they do? You find that I will be open to say it's not really happening at many of our institutions, because obviously if it was happening, the situations which our university institutions find themselves in could obviously not be happening. All those issues of maladministration, mismanagement, and all that, they happen because you don't have the data custodians democratized or giving them democracy. But where it happens also, it might be that issue of you trying to sort of give, and then whoever you give access to who abuse. So you get it. There is an issue of those who try to democratize and be open. Then the beneficiaries of that, those who are saying, yes, you can just imagine, I always ask my students, if you get access to the university system, what will you do? The first thing is upgrade all my marks. I will update all my marks. You hear the other ones, hey, say I'm owing a lot, I will clear my debts. You see, so you can see those are unethical things that can be done when people are democratic. And democracy in a nation we talk of, we are in a democratic state. I can talk anything that I want about the president, right? In those other continents or countries where people are not democratically allowed to expose or say their views, you would find that once you say something bad about the leadership, the next thing is prison. You are traumatized, you are what? So our universities, do they have, are they able to, are they ready to? And that's the key question. And we are saying if it can happen at universities, it is a very good opportunity to spill over to municipalities, to other government entities, because they learn from us. So actually, those who are at university, you will see that if universities are struggling or going to courts, losing courts, cases and what, the government officials, then when you try to comment, they say, no, go and fix your universities. So as academics, we don't have even a word because they are saying you are also in a mess. When universities are taken to courts by students over marks to just say, should a student graduate or not graduate? And the university say, no, the student can't graduate. Student go to court and win in a court of law to say, yes, can graduate. Then the university professors from such institutions are supposed to comment on when our mayors, our what are misleading or accused of corruption. It becomes a problem. That's why I say it's a big talk which we need to. The reason why we picked this topic and this research is actually the fact that there is a lot of data that is available and generated from university systems, and it could be data about students, it could be data about employees, but obviously if we look at the data about students themselves, it's a lot. You find a lecturer teaching the whole semester and not really understanding or being able to identify students who want attention or further work or task to the extent of going even to a final exam. We had a very interesting case as an example this year at my institution where a certain course, the students qualified to write. And after qualifying to write, there were 87 in a class. And I think those who have done IT, and so the course is simple, I will tell them because I told the lecturer that I will say it because personally I'm not convinced that if we had utilized the data we have, we're going to be here. Out of 87, only 7 passed the main exam. Pass as in getting 40 plus. The rest of the students failed, but they qualified to write. Remember, they had a DP, they wrote, then only 7 passed. And the marks, like less than 27 in the exam. And you say, oh, how did it happen? For systems analysis and design too. Did you not have data to see that there is? So we are saying this is the challenge which the data, I'm just speaking of one course for students. In a class, you should be able to see and identify because the data is there. The systems are there. But the challenge we have is, as lecturers, we are also limited because you have no access to more information about the students, and what you have is you only get it when you get the first tests and the second tests. And after assessment, that's when you can get. But there is a lot of data which the students complete on the application form, which you may utilize to say, as a university, students coming from these schools with this background, possibly they struggle in mathematics, then they need possibly initiatives like this, that. It's not happening at many institutions. And that's why you see a lot of dropouts at universities, a lot of challenges where students strike. Remember, when they fail, the next thing they strike. And you wonder at our university, but we are not utilizing the. So it's us creating the challenges which we are facing because we are not providing the users with. Okay, we're saying the need for data democratization, like in South Africa, we obviously bridge the digital divide. Because remember, it's the same data that can be used to actually say a student who is from very rural, remote area, an 8 class student, a 90% in mathematics for a student who is in a well-up environment, in an urban setting, a top school, right, is likely to be equivalent to a 62% or 58% for a rural learner who is learning mathematics in Xhosa. Do you get what I'm saying? Because the student has no resources, but the student did all he can and does, and in the end got a 58 or a 62. Then we deny that student to go to a top university because he's having a low mark in mathematics. But if we looked at the condition that the learner has or has been studying for him to, you find that if you take the same student and give him, put him at a top university with those who are good, or those who have 90s, they might actually all perform the same. Because they now have the same lecturer or the same facilities to learn. So these are some of the things which we say it is an opportunity to bridge the digital divide where those students who have not are able to be in the same setting and environment where with those who have and perform good. universities, they capture a lot of data about students, about their employees, and you see, we are asked to do a lot in terms of professional qualifications and improve your qualifications and all that. But universities, when we complete those, they sit with them, they don't give us promotion. Or even just say, oh, we have noticed that you have upgraded your qualification, you have another professional qualification. How about we give you 2 more or 1.5% increases, right? They don't do that, but they have the data sitting with them. So we say it actually enables, if it's fully utilized with the data they have, it allows HR to see who qualifies for promotion without even asking us to be promoted. Why must I write this? The file for promotion, it's like this size at university. You have to file everything, but they have all the data. Instead of you going to class, you are busy filing and applying for promotion. Most academic or admin or what, they have no room to do or perform data analysis because they are limited. If you do one step, you pass on, the other one handles. That's how the systems are. You can't have access. If I mark students, I capture, at times I'm not supposed to allowed to be calculating the final mark. Someone at exams does that. So how am I even going to know that my students have performed like this? I'm told I have to start taking their marks, their DP, calculate separately and seeing that yet marks are required the next day after writing. It becomes so difficult to manage. And the universities also spend a lot of money in bringing consultants. Most universities, they use ITS, and we don't own ITS. ITS is supported by someone. Each time there is a problem, they are brought in, they support, they charge. Some of the things which can be, then universities spend billions on systems and all that. We just try to use a systematic review to check, scan around what's happening around the universities and consider related data sets on data democratization. Unfortunately, when you do it and you include data democratization in South Africa, it returns nothing. Because it's not a word which we are talking about. We are not doing much on it. If it returns, it's just a little bit. Those, of course, already become the findings. We say already, once you specify without mentioning in South Africa, you return something. And you can easily see that data democratization is foreign to South Africa, South African universities. But we think that it has benefits that can assist the universities to perform better. When I checked, then I looked at the case studies, I came across UCT tries to have an open data portal, and they have it stores a number of data sets across a number of disciplines, which could be helpful. And they say this is the data set they have on their open data portal. It allowed them to have an extensive collaboration because people can obviously go to the site and see what's happening. Stellenbosch is the same. They have the data research repository, which is linking them to international and being able to share what they are doing with many other institutions. These are the ones which you could come up with and which are examples of showing what data democratization can do to you. But there are principles. You find in terms of the findings, as you have heard earlier, we said the universities spend a lot of money, not fully utilizing the data that they are generating. The consultants have to be brought in to give us the data which we are sitting on. A consultant is required, and you pay again for consultant. And actually universities, all of them, the ICT department is ballooned with many people, and what they come to work every day, and they come and work more than all of us, but they can't do any analysis. When analysis comes, they call a consultant. And we want our universities to be rich. Then they also spend a lot of money on training. At my institution, if you want training, anytime they give you, you go, you get training. If you say now I want to go on training, they pay. They have huge budget for training. But after being trained, am I be given access to do analysis? No one give me access. What do? You still stay where you were. They don't capitalize on the training that you have obtained. Now we end up just sitting with trained qualifications and on data analytics, big data and data science and what, which I am not utilizing. Then when I find a good industry, I go and join a good industry. The academic fraternity get angry. But there is high labor turnover because of such things. And universities who have spent data. Now the data democratization itself, the moment people, you check what data democratization is all about, I tell you, many of our normal people, I am talking of normal managers in universities or leadership positions, they will already walk out of the door the moment you bring what data democratization includes. Because the first word is transparency. Do they want to be transparent? Just transparent is so fairness and do like many of them, they are not very comfortable. It talks about accountability. Our managers, our leaders at universities, do they want to be accountable? It's always simple. I used to be a head of department in one institution. My staff, for a thing which they have done, they will say, no, I didn't do it. When students fail, the management does not ask the staff, they ask the HOD. Then I always used to say, no, for my staff, I will fight for them. If they make mistake, it's me, then who is to be blamed? And they used to like it. When they got a new HOD who will say, I will call you to come and account for yourself, they become angry. Accountability is a problem. Then empowerment. In democratization, you empower. It is what all the people need. There are some people who need to feel part of and what, but you don't get it if our systems remain like this. That's why we say at least let's go data democratization and provide empowerment and sustainability to our workers. They are then able to perform well and enjoy going to work than to just go work in a system, pass on some things. You don't even have room to expand or get information. These are other components which are key in the data democratization. It involves policies. Policies required. Most universities, they have a lot of data, but no policies that talk to the data that they generate. In the end, how can they democratize when we don't have that data? So governance, again, is another example, which we also lack in universities, and universities sort of struggle to spend or focus on data governance. The benefits are a lot if you go data democratization, but the only problem is we need to change the whole system of how universities are run and managed for us to be able to benefit, to enjoy these benefits. Some universities have started doing that. Some are still lagging behind. And the implementation of that challenges, it involves just data audit and the clear data access policies and what. So it involves the universities spending on what they are going to benefit from. But in most cases, no, universities, what they want is what they want to build hostels, they want to build. It's easy to spend on building, but the data which is in their system, they don't really want to spend with. Invest in technology. COVID has taught us that universities must invest in technology. Now I think they are a bit better than what they were. When we were talking to them about investing in technology before, they were not willing to do that. There is an issue of legal, ethical, and technical issues, because if it's data democracy, if our constitution is also not very clear now. If I do something illegal online, Like at my institution, I think it's a popular thing. You have that, you are aware of the incident where a student was paid 14 million from NSFAS money, and the people who paid it, they are there. That's the thing. What you ask yourself is, once you give people access to the system and they abuse it, then what? So we need proper legal, ethical, and technical issues to be addressed before that democratization happens. And our people, in most cases at universities, they then lack those technical skills of knowing. That's why they can easily say, no, it was a mistake. I didn't know by clicking this, it will take me there. And that's the thing. Then there are other emerging trends. I see my time is up in terms of future direction. Data democracy requires fair data principles. You have to adhere and understand. You have to understand the data. Open data is not a case which we can just approach without proper plans. This is why we want to engage all the citizens and try to have, at my institution, we are trying to establish a task force team that can try to work towards this data democratization. And I think our management is in support of it because of the benefit they are seeing, or they are seeing from us. So it's a call to those who have interest in that data democratization. If you start it at Walter Sisulu, my institution, I tell you, you take it to UP, you take it to what, it will work, and because our systems are limited and not so there. So if it works there, I tell you, you then be able to easily implement in other institutions. Again, these are some of the examples which you benefit or reach when you invest in data democratization. And obviously, in terms of conclusion, there is a very good potential for universities. It will actually cut on many costs for them in terms of spending, in terms of system management, in terms of minimizing on consultants and all that. But it's all about change management at universities. It's all about transformation and transforming the higher education. And remember, transformation, when you want to bring it, majority of them who tried to do or talk of the word transformation, you see them where they are. It's in higher education, it's not easy to transform. Whether it's about for academic good or bringing new systems, the moment you do it, you are already in trouble. So we need to work together and be more inclusive in ensuring that we have data democratization. I think with this, these are some of the references that I have used, which have a very good information on data science and democratization, which I have used for this presentation. And with this, I thank you. Thank you.
Good afternoon, everyone. I think it's past 12 or it's 12 o'clock now, so it's suitable for afternoon. My name is Kinelwe. I'm from SEON, and I'll be presenting the South African Risk and Vulnerability Atlas. Well, it's always important to introduce where you come from, and I come from the South African Environmental Observation Network. It's basically a business unit of the National Research Foundation, and we report to the Department of Science and Innovation. Basically, the vision of the organization is to do long-term environmental observations. That is our main core focus, and we've got established terrestrial nodes and marine nodes. As you can see, I don't think the pointer works. Oh, there you go. We do have nodes all over South Africa, but we have two which are focused on marine, which is Elwandle. It's based at the Nelson Mandela University campus. We've got Egagasini based in Cape Town, and that's offshore marine. And we've got 4 terrestrial nodes, basically focusing on different biomes, doing research on different biomes. And the node that I'm in focuses on data and information management. Yeah, as I mentioned before, basically SAON's approach is to do long-term research, environmental research at each of the sites. The intention is not to have a national footprint, but to have long-term observations over a certain biome for a long period of time. And the main 3 focus areas for SAON, it's basically environmental observations, data management, and education outreach. And we're also hosting the South African Risk and Vulnerability Atlas, which I will be presenting later. What we also host is we've got research infrastructures. I don't know if you guys are familiar with the South African research infrastructure roadmaps. We are hosting 3 of the research infrastructures, one called EFTON, which basically focuses on terrestrial observations. It's expanded freshwater and terrestrial observations. It's basically inland. It's inland. And then we've got SMACRI. Oh, sorry. We've got SMACRI, which focuses on shallow marine. So basically, they do research all over the coast, but focused on shallow marine areas. And then we also have SAPRI, which is called the South African Polar Research Institution. Basically, we do research all the way down to Antarctica and the Marian Islands as well. So you can imagine with everything that I have mentioned in my introduction, from the terrestrial nodes that I introduced to the marine, to our research infrastructures, the data that's being collected, it's actually quite a lot because we do have near real-time instruments taking data. So how is that data managed and where is it stored? This is where the node where I'm working in comes in. It's called Ulwazi. It's the Data and Information Management Node. Ulwazi, meaning knowledge. And we are based in SAON, so we manage all of SAON's data. The node basically comprises of 4 components, where 4 teams, rather, I would put it. We've got the infrastructure management team. Basically, those are the people responsible for maintaining our servers, for setting up the servers, for anything systems, infrastructure management. We've got the data curation team. These are the people who are responsible for the metadata and curation of data so that we are using the correct standards and schemas. And then we've got the systems development team. These are the front-end system developers and also back-ends responsible to give us a system for our data curation and some of the complicated dashboards that we create. And then where I sit is in the 4th team, which is the data science team. I work as a GIS analyst within the team, and basically what we do, we'll do your machine learning analysis, we will produce dashboards, atlases, and so on and so forth. So now that you know a bit about me, where I come from, what we do, I'll be presenting you one of our projects, which is called the South African Risk and Vulnerability Atlas. Basically, the South African Risk and Vulnerability Atlas has been running for over 10 years now, and it's in its 3rd phase, and it's now here at SAON. I think it started at CSIR back in 2008, and it was a hard copy book. And as it evolved, there was a requirement that it needed to move away from being hard copy, and it must be web-based, and it must be searchable so that the data that it presents is always updated with time. So basically, the 3rd phase of this focuses on data access and value-added products for decision-making. The South African Risk and Vulnerability Atlas, I think the main users, right now we've broadened the scope to include everyone, but its intended users were policymakers, your municipality decision makers, and all those people sitting at sitting at high up levels for them to make decisions regarding risk and vulnerability regarding the areas that they are in. So at the core of this project, there is a spatial database and information management system that I will introduce, which I think relates well to this conference. Basically, it's the SAON open data platform that we have. If you can go on our SAON website, you will find that we do have a SAON catalog, and that is the backbone and the back support of the server system. Basically, it's a web-based development platform where all the data that we have collected can be found. As mentioned, it's an open data platform, so people do submit their data. We use openly free available data sets and they are also curated, and you do get a DOI, which is a digital object identifier, to say that the data set was created by you. So we don't own any ownership of the data set, but you can use our platform to store your data and to make your data accessible. Basically, it uses a system of systems. We run a lot of different projects like the South African Risk and Vulnerability Atlas, the Bioenergy Atlas. So what we'll do is that all these data sets will be stored within our open data platform, and it's accessible to both systems. So if you go on the website, on the Bioenergy website, you will find some data linking to server that can relate to bioenergy, hence the concept of systems of systems. I like that the previous speaker mentioned the FAIR data principles. For those of us in the room who don't know what actually FAIR stands for, it means that your data must be findable, it must be accessible. Most importantly, it must be interoperable, meaning that your system cannot just be one system that speaks to itself alone. It must be able to speak to other systems. And for instance, right now with us at SAON, our open data platform is also interoperable with other systems to such an extent that we are able to collaborate with international systems such as the GEOS. When you go on the GEOS or iAtlantic, you are able to find our data sets through collaboration. And most importantly, lastly, it needs to be reusable. So if you do have a link embedded from one of our own data sets, you can then use it in your own website, but just citing our DOI. So this is what it means that the open data infrastructure must be fair, as the previous speaker mentioned. So this diagram basically explains how our entire system works. Towards here, this is us, the 4 teams working very hard behind the scenes. And we'll have the SAON Open Data Portal, which is our catalog. And you know that it's based on the FAIR data principles. And I think one of the most important one, I will also talk to this a bit later on, is that our data repository is Core Trust Seal certified. What it means that it has attained an international certification for it to be a trusted repository, data repository. For you to attain this, it's quite difficult at the moment, but it's important for people to know that their data is stored in a safe place and it's a trusted repository, that when you go to that data repository, the data that you're obtaining is true data. So basically behind all of that, this is at the top is what you see in front. At the bottom, it's what's behind. The data sets that we have, which is distributed data sources. So we basically have data from all our instrument and observations. As I mentioned before, going back to my first slides, you saw where we collect all our data, where all our instruments are based. We do have automatic instruments uploading data almost near real time. So this sits down here and it sits in our observations database. And we also do get data from model outputs, such as our ocean modeling guys. And then we've got spatial and multi-dimensional data sets, such as your NetCDF's data, and we've got file objects data and individual data sets, which we all create, curate and make open on our open data platform. The curation of all these data sets will obviously be different because they have different metadata standards and different metadata schemas, but we do adhere to all of that. So basically, this is, when you go on our website, this is how the data catalog looks like. And you as an individual, you are able to submit your data to us where we can store it for you and offer you a DOI. And you are also able to search for data sets. So hence it's a system that you can work quite fast with. So basically, you now understand what's behind Sava and how you could search for data in Sava. So as I mentioned before, Sava is the South African Risk and Vulnerability Atlas. The most important thing to note here is that the top 5 global risks, according to the World Economic Forum, that were released this year are written here at the top. And out of all this risk, the top 4 are environmentally based. So this is just to drive the message of the importance and the need for environmental data and long-term monitoring, because we do realize that as we face droughts, floods, all of those are environmentally related. Bringing it back to the South African context, we did then in Sava map the hazards to the Sendai framework, and here we're just using the GMAT vocabulary. So this is all the hazards relevant to South Africa. All this data is found in the Sava Atlas. This is basically just to highlight the disasters in South Africa that we have faced from 1980 to 2022, which is basically last year. And I think if you could pick up from here, the last year we experienced most floods, and this is actually where we spend most of our mining in. This is also just to drive the message that what we're doing is really important, and data for this is really important so that we know what trends to do. And also our data and indicators are integrated with the SDGs and the Sendai framework for disaster risk management, which is very important because as a country we do need to report on the SDGs, and Sava speaks to policymakers, so it is a good data portal to come and get indicator-based and Sendai framework tagged data sets that speaks to the SDGs. So we do at the moment cover 15 out of the 17 SDGs, and we've got the data for that. If you go on our website and just click on them, you will find data. We also do product development such as dashboards and tools, decision-making tools. So this is one of the examples, which is the climate risk profiler. Some of the data is not from us. As I say, we do collaborate with other institutions. We have data sharing agreements, and then we do put that data in our portals or the dashboards that we have created so that it's easier to understand for everyone who is not within the data science. One of our atlases, again, is the natural disasters of South Africa, a very important one to know which provinces are at risk. We have also created the National Climate Change Information Systems. This was a project for the Department of Forestry, Fisheries and Environment. We are the people behind this, and the data is also accessible through the Sava portal and our open data portal, SAON. So coming to this point is the independent audit certification and interoperability. I think I've already mentioned that this year, 2023 in September, our portal was certified by Core Trust Seal as a trustworthy repository. This is a very difficult certification to get. Basically, right now we've got 160. The Core Trust Seal is part of the World Data Systems, and there are currently 160 plus data repositories that are certified within this system, and we are currently one of 2 in Africa and the entire continent. The first one to attain this certification was UCT with Data First, and this year SAON managed to certify their repository as being trustworthy, and yeah, it was a very big deal for us, and we're still celebrating. And the last point is that we are interoperable with the Group on Earth Observation GEOS portal. Group on Earth Observation is quite an important multinational organization, so our data is findable through them. So someone could be searching from our data sets in India and they will find us there because that is interoperable. So in conclusion, SAVA is a living atlas. We keep on updating the data sets with almost updated data so that when you're looking for risk data, you don't find data sets that speak to 10 years back. It will be something that is right now. And all components are open and reusable. We do have links for our dashboards that you can embed in your own website. Just need to accredit where you found it. And we need to continue to work together to continuously update data so that we are well informed on what's happening to us within our environment and our global systems. Thank you.
So good afternoon, all. I am Don Matlobo, as the chair has already said. I'm coming from the Weather Service, the South African Weather Service. In short, we call it SAWS, so I'm coming from SAWS. So if you want to have any reliable, accurate data, come to SAWS. We are the people. So data is quite critical for our operations. So when you're talking about meteorological data, as I've said, we are the people to go to. And this is one of our, of our objectives because we are the custodian of meteorological data as well as air quality data over South Africa. And we do ensure ongoing collection of these data sets. So one of the functions of SAWS is to issue severe weather-related warnings over South Africa. So we are the authoritative voice to do that. So you cannot have any severe weather alert that is not coming from SAWS if you're in South Africa, if you want to be safe. And we also have a number of destinations from our umbrella body, which is the World Meteorological Organization. We are the Regional Specialized Meteorological Center. We are the Global Producing Center for Long-Range Forecast. We're also the Regional Training Center in Africa, in the whole of the continent. So before I go on further, so you know where we come from, just to give you the weather for today, from the Weather Service. So we expected 90% of humidity around 8 o'clock, down to 50% this afternoon. We do expect possibility of showers and thunder showers. There was a possibility around 8 o'clock. And then in the afternoon, it should be cloudy. As you can see outside, it is quite cloudy. The direction, from 8 o'clock, it was southeasterly to easterly in the afternoon. Then wind speed throughout the day, it will be 9 kilometers per hour. And we forecasted a temperature of around 29 degrees Celsius at 2 o'clock this afternoon. Rain amount, 3 millimeters for today. Sunrise, if you have checked, we have forecasted 4:54 as our sunrise, and sunset at around 18:33 or close to 6:30. So that's the forecast for today from SAWS. So let me take you through our journey regarding the data from SAWS. So we have data as far back as 1836. So this is manual data, your rainfall data. And then from 1884, we have other variables like your minimum, maximum temperatures. The hourly data, because as we evolve, the resolution, our temporal resolution improves. So around 1950, we have hourly data of number of parameters, your wind speed, direction, temperature, humidity, pressure, and sunshine. We also have upper air soundings from 1961, marine data from 1975, and forecasting data since 1990, satellite data since 1992, and also have radar data from 1994. As I've said, we're coming a long way with our data. We have hard copies, data in hard copies, dating back as 1850-something. So we still have those type of data, and this is quite a challenge for us. We're in the process of digitalizing such data set because it is valuable. I mean, you cannot say anything about weather if you neglect your weather data. So we have this important information, but in hard copies, and we're trying hard to digitalize it. With our limited human resources, as well as limited computational resources, we're really struggling, but we will get there. So this is one of our challenges from source. We have different types of data. We have data, terrestrial data, oceanic data, and atmospheric data. We have 235 automatic weather stations. So this is at the resolution of 5 minutes. So we have 5-minute data from 235 automatic weather stations. So due to load shedding and a number of issues we've been facing throughout the country, these stations have declined to this number. So we had a better network some few years before COVID happened. But now we're down to 235. Automatic rainfall station, we have around 163. We have 1,128 rainfall stations. So these rainfall stations, we rely upon volunteers to take readings. And some of them are getting old. Some of them are passing on, and it's a challenge. Youngsters, they don't want to volunteer anymore. So this is quite a challenge. Hence, we're trying to modernize our stations. So we are moving from manual stations to automatic weather stations. We also have 6 UV stations across the country. We have solar radiation stations, biometrical stations, and air quality stations. As I've said, we also have oceanic data from sea surface temperatures, drifting boats and voluntary ships, and atmospheric data from 11 upper air stations in the country, and then 13 radars, aircrafts, 3 Dobson stations, and 24 lighting detectors. Also have 1 satellite station. So this is the current network, South Africa. It is quite impressive, but we do have gaps, and some of the gaps are in very disaster-prone areas. So we really need to work. So we are trying to collaborate with other organizations to fill all those gaps. So it is a work in progress. So you've heard some of the presenters yesterday, they talked about models. So models cannot do anything. We cannot talk about models without talking about the data that is ingested in models. So as source, we are contributing data from 160 automatic weather stations at reporting interval at 3 hourly for surface level pressure, temperature, humidity, wind, precipitation. So all of these are ingested in models so that we can have better prediction of the atmosphere. So as you know that the data network from source, it is quite promising if you look at other data sets in Africa. So you find that some of the countries, they contribute only 1 or 2 station worth of data. And then such data is supposed to be ingested in models. So South Africans are really playing a huge role in making sure that we have good data assimilation for our models through our data network. SOURCE has 2 mandates. One is the public good, to offer public good services to our communities, as well as commercial services. because we really do rely on commercial revenue for our operations. So these are some of the commercial products that we are offering. They are sector specific. Some of them are client specific, like your animal histories, your evaporation data. We also have a number of products talking about drought. We have your heat and chill units. So we have a number of products that we are offering. But we have also a number of products that we're giving freely to the communities, to our communities. So we really do care for South Africans and their well-being. This is some of the publications that we are offering to our community or to South Africans. So we also have a database of severe weather events that occur in South Africa. But we really we are working on this, want to link all the severe weather to the systems that are responsible for those weather events. So as you know that our location in South Africa, in the continent, we really along the subtropics, so we're influenced by a number of systems from the tropics, from the subtropics, and from the mid-latitudes. If you can look at those pictures on my right, you can see a number of disasters that occurred in South Africa. And mostly of these are from the tropical cyclones. So tropical cyclones are responsible for your landfalls along the east coast of South Africa. We also have subtropical high pressure systems that transport moisture into South Africa. So if you can Google my latest paper, I'm talking about the impacts of these subtropical cyclones, the Hartley circulation, and how it affects the weather of South Africa. We also have mid-latitude systems that are responsible for the migration of frontal system, the northward migration of frontal systems that causes rain in our winter rainfall region, that is your southwestern Cape. And then some of the effects are coming from our warm Indian Ocean, as well as our cooler Atlantic Ocean, as well as the steep topography that we have in South Africa. And this is not really captured well by most of the models, but as Robert presented yesterday, and patients that are working on this, so that our models can be able to capture the topography of South Africa as it's supposed to be. So these are some of the severe weather events. The previous speaker talked about your vulnerability atlas and how you categorize your severe weather events. So this image here has been done by collaborating with some of our scientists from Sion. So we are looking at a number of severe weather events using one of our publications. Maybe you know all of it, most of you, the Kalium. So it lists all the severe weather events within the country. But then we still have challenges with that publication. So if you can look at the pictures here, you have your droughts, and then there's quite a number of them along the eastern parts or the southeastern parts of the country. Also have floods, your storms, and your wildfires. So these are some of the severe weather events that we experience in South Africa. Yes, I'm rushing. But we want to take a step further, not only just documenting all the severe weather events, but want to link all the severe weather, the impacts with the systems that occur in South Africa. So as I've said, we have a Kalium. It was originally as a hard, in a hard copy, but we've moved towards this hard copy to an Excel spreadsheet, but there's still limitations. And some of the gaps that we have with this recent Kalium or publication is that there's limited data sources, there's lack of information from local sources, so we don't have people or citizens participating in the archiving or in the reporting of these events. There's no consistency in reporting. So we're moving from these to a database that will take into account the systems that are responsible for severe weather events, the exact location, and this is the SWEDE project. The SWEDE stands for the severe weather, the severe weather database. I can't remember what the I is standing for. So we're trying to archive this system systematically so that they can align with how WMO, our mother body, categorize the severe weather events. So the events will have unique identifiers, where they originated from, that is your weather systems, where the record was created, when it started, when it ended, the type of event. Because sometimes when people report, they will say it was flooding. Some say they will say it's extremely high rainfall amounts. They can't differentiate. But with this SWEDE project, we'll be able to categorize all these severe weather events by their actual source, the type of weather systems that are associated with those events. So that's our SWEDE project. I'm rushing, but as I've said, we do have some challenges. We're getting somewhere from hard copy, data in hard copies to automatic data, but we're not there yet. I mean, the world is evolving, AI is happening, and we feel that there is a specific role, a very critical role that AI is supposed to play in the management of our data, also in quality control of our data. Currently, we are manually quality controlling the data as per WMO specification. As I've said, when I started, I said, if you want reliable data, if you want accurate data, come to source, because we take time in making sure that we quality control the data for our community. As I've said, we challenges with data in hard copies, but we're in a process of digitizing the data. And I've been listening to a lot of talks since the beginning of this event. We have quite a number of intelligent people, data scientists that will be able to assist us in trying to solve most of the problems that we experience with our data. So digitization is one of the things that we're trying to do. If it can be automated and maybe use AI to assist in the digitization of data, that will be a plus for source. Also looking at the data filling, because you've seen our network, there are some gaps, and some of the gaps are in very disaster-prone areas. Some of the storms that are critical we miss because we don't have a network that is dense enough to capture some of the storms. So we are trying to find ways in filling all those data gaps, and also improve the resolution of our data. Right now we have station data, but we want to have a very comprehensive gridded data set from 1800 up until the current time. So these are some of things that we are hoping to achieve in the next few years. Thank you so much.
Spending money on consultants. I just want to find out what is it that is stopping these universities not to develop their own the capacity within, rather than spending money on this consultant. The second question is around transparency and accountability. Don't you think that these institutions are infiltrated by politicians? Because to me, the people that they don't want to account are politicians. Thank you very much.
Okay, so in terms of the using their own resources, I tell you, I teach, for example, development software 3. My students can develop better system than the one which we use for the learning management system. My students can develop the system, the online application and registration system better than they are using. But maybe I would say a black child is not trusted in terms of delivering. It's a mindset which we need to change and start looking at. Even when they present, they, oh, it's all good, wow, it's all good. Then when what's next from here, no one takes action. But they still trust and spend on systems that are externally sourced. So I think for me, it's just about the trust which we have among the community, which is a big problem. I think it even expands to even the government. In most cases, if you go present a nice solution to a municipality, they start then asking, what's your track record? What's your, you see? So it's not easy to get into that space. The other part I did not get. Yeah, no, obviously politics gets into the leadership, and if you are in support of what the like the ministers of higher education, then even if you are messing up, you can still survive. So there is a link between the two, and the universities are sort of struggling to separate themselves from the government, which is also another problem that I see. Thank you.
Pure out of curiosity, addressing Dr. Mahlobo, there's always this confusion when there's 80% rain, whether it's 80% of the surface area that may have precipitation, or there are 80% chances of rain. Which one is the correct one? And then the second one, there's always this maybe potentially controversial topic of weather being manipulated. Is it ever factored in their projections? Thank you.
I'll start with the second one. So whatever we do at source, we're guided by the World Meteorological Organization. So we don't tamper with data. We don't tamper. We don't try to look good to you. So we keep the standard as it is. So we take strict guidelines from WMO. So that's why at some point we'll say source has missed it. They didn't get this one, but other companies out there, they got it. Because we really follow strict guidelines. You don't want to seem like you're champions when it's not like that. So we really acting based on strict WMO guidelines. We don't tamper with data, we don't tamper with forecasts, we say it as it is. 80%, that's a chance, that's a possibility. But when you look at the possibility, your seasonal forecast or any other forecast, the possibility, it also talks to the distribution. So you cannot have 80% in quite a smaller area. So they work hand in hand, they go hand in hand. Do you understand?
I'm more confused.
Okay.
Hi. So what I heard the forecasters say is that 80% of the area that cycle is having those chances has 80% chances of experiencing whatever the rainfall that, let's say there's like 80% chances of 10 millimeters of rainfall, and they've cycled maybe an area around Gauteng. So that area, 80% of it has 80% chances of receiving that 10 millimeters of rainfall.
So in short, the probability always goes with the distribution. You cannot have 20% of rain over an 80% area. So distribution and probability, they always go together.